All right, so today we have Anant Bhardwaj, CEO of Instabase, which you can find at instabase.com. So here's a few things from their website. AI native unstructured data platform. Unlock the potential of your enterprise data with AI. And this one I like especially. Automate processes, find information, and make smart decisions faster. And with that, Anant, welcome to the podcast.
Thank you so much. It's great to be here.
And we're talking the day after ChatGPT 5 was released, so maybe we'll briefly touch on that. But let's start with the hot topic right now in Silicon Valley and beyond, which is agents. So it's kind of a vague term. So how would you define what an agent is? What makes a true agent?
Yeah. So my definition of agent is very simple, and that is it takes only two input, which is your goal and the set of tools, and that is it. It has all the freedom to do whatever it wants, as long as it can use those tools and give you an outcome. That's it. Or it can fail, or it can misuse your tool. It can do whatever it can do. It's like humans. You gave it like, hey, here is your hammer and nail and the wood and whatever. It can make a great sofa. It can make a bad sofa. It can give you something that you don't like. So the way I define agent is literally a goal and a set of tools. Under the hood, what agent does is, given the goal, it's going to figure out what should be potential plan. After executing one step, it might realize that plan is wrong. Go and change the plan, and maybe like use some other tool or ask for more information, whatever that could be. It will keep doing, and it makes a self-determination of when to say I'm done. So you have no control. You give set of goals and set of tools. You have only one control, that is to kill the agent. Like, hey, I don't want you to do anything more.
This is an actually excellent way of explaining what an agent is. So obviously, a few years ago, for the older listeners there was a term that was bandied about called robotic process automation, right? So which is very different from what Anant just described. So one thing that you folks have argued is that AI agents and automation will basically wipe out RPA, robotic process automation. So please explain.
Okay, so before I go there, let me explain what robotic process automation is, because I think that's an important one. The robotic process automation basically means that you record how I have done something once and robotically follow exactly the same set of things. So you just do what I did. And so if human pressed on this button, which is 5 pixels below from the top and 2 pixels from the right, you exactly go and click there, and whatever screen comes, you have to click 10 pixels from the left and 20 pixels from the right and do whatever. So that's called robotic
So
process.
for people who use Excel and used to record Excel macros, that's basically what it is, right?
Exactly. Just think of macro, which is not just formulaic, but more of has some kind of like where on the screen certain things should be clicked. So that's robotic process automation, and it has value because you would do something and it's which is mundane and boring, and you just record once, and then if somebody can keep repeating the same set, life is good. It's a good automation.
It led to some interesting and big startups too, right?
100%. So yeah, so there is value. So first, I just want to make sure that people do not misunderstand when I say it will wipe out RPA, as RPA has not produced value. It has produced value when a task can be defined as exact replica of keep doing the same thing. Do not change. But as you know, in life, most problems tend to be unstructured. Your tomorrow is not exactly same as today. So if you give her a bar that exactly take 10 steps ahead and 2 steps left and 2 steps ahead, you might, not be very happy. So there is an opportunity where what if we talked about agent just in the last question, because where agent can decide maybe here are the set of things I need to do to get to certain goal. And if the first step basically says it's raining, then I might need to get an umbrella so it can figure out how to get an umbrella and then move forward. So I think now, especially with the advanced capability in these large language models, which basically allows you to define a plan and at every single step reevaluate the plan and figure out the next steps. You can do all of those things that RPA was able to do without needing to do this recording and replay. So that's what I mean. It will wipe out. Now, there is a question that would come is predictability. Because earlier you had complete predictability. It will go only 8 pixel below and 4 pixel left. It will exactly click there. Here, what if agent decides to basically get lazy and not move any steps? Because you have no control. You just give it a goal. And that's why what we believe is uh, that agent can create something because it has the autonomy which you can review and then so that you know what workflow agent is going to do and then you run that in production, which gives you predictability. And there are some early successes of that, like coding, right? Like it tells you, I'm going to go edit this file and change this and do this. And you say, yeah, looks good, go do it. So it's still, you have to say, looks, because what if agent went and deleted all your code base? I think there was one example recently where it deleted some production database.
Oh yeah, yeah, yeah.
So you need some degree of control, but I think that with a nice system design and properly building system, RPA would be fully replaced with the new intelligence that we have with agents and workflows playing different part during build time or runtime.
So in your folks' work at Instabase, right? So obviously you're starting to build and deploy agents, right? So maybe give us a sense of what types of agents or use cases you're fairly comfortable these agents are doing great, right? So and in what kinds of use cases do you think the agents are still falling short and where there's still work to be done on the foundation models?
Okay, you have touched upon a very meaty question. So let me first clarify that we have a slightly controversial point of view
I
on
love controversy.
deploying agents. I think that, and let me give you one example in the real world, the real human world example, and then we will get into more AI.
No, yeah, yeah. I want an example where it shines and an example where it's still kind of struggling.
So let's take a human world example where basically, I'm sure humans have intelligence and they can make their own decision. That they're a great example of agents, right? That have intelligence and autonomy to do something. But if you look at most of humans, they cannot make what they think. They have to follow the rules of the organization they're a part of. If you are a hotel receptionist, you have to exactly, do the things and charge the price. And so having agentic or intelligence capability does not mean that the world should run where every person is making their own dynamic decision. So we believe that in general, agents would not be runtime production phenomena at the much broader level. You will still have like small tasks where we can do things. So agent is going to be more of a build and design time phenomena. So and let me explain that. So let's say we want to build a process for like how do we do our let's take a hospital. They basically, how do we serve a patient when they come? We look at this data, we look at some certain things, and then we look at the rooms available, we look at their insurance history or whatever, we put them in a room. So I think there are some initially smart set of people who sit together and figure out that when we build this hospital, this is the exact set of workflow that will happen. And we call this build and design time thing, where you need a lot of smartness, intelligence, thinking, brainstorming, whatever you want to call this. And I think that agents could be very useful for that because it's not running, it's designing, because then human can collaborate with the agent. Oh, this looks good. No, can you change it this way? Can you change? And so you basically kind of like an human and AI collaboration as an agent is going to be more and more successful during build time phenomena. So that's our controversial opinion. It will not be a runtime phenomena. Runtime phenomena is going to be once human okays that whatever workflow that we figured out, that when it comes, it goes in this room and then they do these checks and then these tests, and based on that, you go there, then you always run those because then you bring a degree of predictability. And we call that, the term that we use for that is called AI workflow. So agent, along with human, in the beginning, use full agentic capability and iteration capability to come up with something that is much more predictable. So we believe that the whole agentic buzz, that the hype or reality, whatever you want to call it, is going to be more valuable during build and design time, not during runtime.
So let's translate that example to a knowledge work example. So let's say I'm an analyst in Wall Street, right? So I'm supposed to come up with some prediction of earnings for next quarter for NVIDIA, right? So then my normal workflow is, I don't know, gather data from alternative data sources, read everything I can about NVIDIA, and so on and so forth. So what you're saying is I can use an agent to maybe help me design a better workflow.
So that's one way. So I think there are different kinds of workflows. One is the operational workflow, and second one is individual workflow. And let's talk about both separately because there is a very nuanced difference on how they run in production. In individual workflow, you have complete control, right? You are doing it. So you are seeing what is being done. In operational workflow, it happens at the back end, like lending, right? It goes from here to there to, it's not one particular person who makes a decision. It's a series of things with different organizations and teams it goes through. So in the operational productivity, agent would be a build time phenomena where it will help you build and do all the things and checks, and the AI workflows is much more predictable, is runtime phenomena, like lending. When stuff comes, then I'm going to do these calculations, then going to run this credit risk, then going to run this. So you want to run exactly the same way, but agent allowed you to kind of like create all those things and define all the checks and all that. The example that you talked about is the individual productivity, where basically a human is making a decision based on. So of course, human can say, this is how I make a decision. Go do this research, go take data from Bloomberg Terminal and do this, do all those things. But then, so AI agent did that, but then a human does a final check and it says, oh, this looks good. I'm fine putting my name. And then it basically goes in. So basically here, it's still a built-in phenomena, but even during runtime, it becomes human AI collaboration, and then the final output comes.
But I guess I was inspired by what you said because there's a potential there where the agent might even suggest to me, hey, Ben, actually, you're forgetting about these types of data sources, So, because
100%.
traditionally, you do this thing the same way again and again. So maybe you have like a blind spot where you're ignoring certain signals or data sources, right?
100%. In the individual productivity, individual workflow, that would be the case. In operational workflow, no, you don't want like people to come like, oh, I want to change this, and you're basically, and that's where so basically that's why in the operational workflow you will have that during build and design time. Hey, you missed this blind spot, you want to do this, but once you want to put AI workflow in production, you don't want AI to randomly make a decision and change something and insert something, and so I think that part is critically important. So when human and AI are collaborating, you have rooms for those things. Hey, this is a blind spot here, and you see a really good success of that in coding. So coding agents are very, very successful because it doesn't deploy things in production, but during coding, it tells you, oh, you missed this edge case, or this might have security vulnerability. And then humans can change, oh, it looks good. And then they basically say, can you fix this? And then it does it. And then once you feel good, then you put that into production. So agent basically play a critical role mainly during build and design time with human collaboration, human and agent talking. During runtime, you need predictable workflow. You don't want agent like when running, right? Let's say in production, Google automatically change certain behavior, even if it is good. You do not want that because you have unpredictability, and nobody wants unpredictability at massive production scale.
So your controversial view is you're less about letting these agents run wild, full automation without human supervision, right?
My controversial take is agentic is very, very useful during build and design time with human collaboration. It should not be used for repeatable production workflows,
Which is counterintuitive, right?
which is counterintuitive. Yeah,
Yeah.
exactly.
Yeah. Yeah. But uh, even in build and design time, I suppose an agent, I guess it's less critical at that point, right? So an agent who's trying to reason and explore will encounter something that they've never seen before, right? So in which case the agent can, in the case of coding, Claude Code will just burn through compute, man. It will just kind of brute force and resolve whatever Jira ticket you give it. It'll resolve it, but at a cost, right?
Yeah, I mean, I did not take too much cost consideration because I think these costs will get cheaper. So any analysis with the cost is really like, you will see a very different answer 6 months later because the cost keeps going down. I was just more focused on real outcome slash result that is correct, reliable, and predictable because humans basically care about that. Like if you go to hospital, you expect reliability, predictability, and that part is very important.
So your counterintuitive take, right? So let's map that into the canonical example of agents for the last 40 years, which is this booking a complicated travel trip, right? So I'm Anant. I'm gonna go from San Francisco to Fiji to Australia to Rome and back to San Francisco. And along the way, book me all the flights, hotels, rental cars, recommend restaurants, and so on and so forth, right? So I think that's kind of like the canonical example. I don't think it actually exists even for one city, right? So I don't think there's an agent right now capable of helping you do all of that for one city. But if you were to build that agent, uh, or if you were to use the tools we have now today to build a tool that can semi-automate that, how would you go about doing it?
It's pretty similar to how do you go about having an EA, right? You tell them like, hey, go and do this, and then they can ask you more questions, like whenever they feel. So I think you're going to tell AI agents like, hey, here are the things I care about, but if you are not certain, ask me. Don't go and book something I don't like. So I think that the key gap there is not too much technical. It's more about how poor we as humans are in specifying the outcome that we need. So I call this a gap between the specification domain and execution domain. And that gap basically gets reduced when you become more formal, right? You say, do this for like lawyers, right? They're very formal. If so and so and so is such, then this. That's how they talk. But in general, as a humans, we don't talk that way. We are trying to be, and I think that in most of those cases, you will see the agents more of like, oh, I'll go do all the search and I'll meet your this particular requirement and now tell me what to do. And I think that agents is going to be more like EA, like, hey, I've done all this work, now pick the hotel, now pick, like you can make, so instead of like you spending 2 hours trying to search everything, you made the final decision of like among top 10 choices, which took 5 minutes. That's where I believe these agents will be successful, but they would not be like, I've done everything, just go. And you will not be happy if the agents did that.
Yeah, and then they might be able to go into your phone and figure out all the restaurants you like, and then try to find you a restaurant
Yeah,
in that city or a hotel in that city, but with your permission ultimately, right?
I
But
just
then I'm assuming they can, once you give them the go ahead, they have the capability to actually uh, do all of the reservations and bookings at
yeah.
that point, right?
I'm less worried about capability. I'm sure like these are very, very capable system. If we have time later, I'll show you a demo where basically you just simply see where I have an AI where I just give it a control of pressing my keyboard and mouse. So basically my point was at the end, human can achieve everything computing has to offer by just three capabilities. One is you have an eye through which you can see, you can observe the world. That's how you get a sort of like sense of what is around. So that's an eye that, and you can replace that with camera pictures, right? AI can take a picture of things. Second, you have brain that processes those things. And third one is your body, which is hand that you press keyboard and mouse. That's how you can get everything computing has to offer. So if you give an AI a camera, which can take screenshot of your, take a screen capture of your screen, you have LLM, that's intelligence, because I can ask LLM, like, what is on the screen? And then I give computer only two tools, press keyboard and mouse. That's it. And you will be surprised how much it can achieve. It does an amazingly good job. People are like crazy, like when you saw that demo.
So let's switch over to a little bit to enterprisey things. So I noticed that you folks have been talking a little bit about this notion of RAG. Do I RAG or do I fine tune? Right.
Um,
What's your latest kind of thinking along the lines of I guess it's not an either or, right? So it's a false dichotomy, right? So
my answer would be it's neither nor.
yeah.
So not either or. So I don't think it should be fine tuning. I mean, in general, I think I have not seen
Well,
any.
I think fine tuning was a kind of early on. People thought, okay, maybe this might work, but then immediately they realized actually, it only works for data similar to that you showed for fine tuning, right? So
I actually wrote if you go and find the Instabase history, there is an email where is AI going November 2022, just like I think the day where ChatGPT was there, when everybody was like fine tuning and all that. And our first sentence it starts with fine tuning is not the future. There will be few context in place learning, and rather than like, fine tuning. So fine tuning, we do not believe in. I think these large general purpose models is where the future would be. So that's basically first neither. Now let's talk about nor, which is RAG.
yeah, yeah.
So RAG is,
And RAG is just a proxy for context, right? So give it more context.
yeah, but I think
So
RAG
it could be, you could give it like context could be added by search, which is classic RAG, or knowledge graphs, graph RAG, or something else,
yeah.
right?
So
So,
RAG is retrieval, and you can do retrieval through whatever, right? The
yeah,
vector search or traditional search or database tools or whatever.
yeah,
So there's a tool augmented RAG where you can
yeah,
query some database.
yeah.
Um, I think I think that depending upon the situation, you will get a wide range of valuable outcome from RAG, and which could be negative to zero to good ones. And I'll tell you why I'm very
Yeah,
like
yeah, this is like a misnomer that people think, oh, since I'm using RAG, there's no hallucination. Right.
no.
Yeah, yeah,
It's not, it's worse than hallucination. I'll tell
yeah.
you why. I'll tell you the problem with RAG. RAG basically said, I'm going to go and do some retrieval. Let's say like I have a bunch of corpus and I select like top 10 chunks and I'm going to send that to the large language models. What if your top 10 chunks miss the answer? You basically didn't get any answer. So so basically recall is one of the biggest problem with RAG, which is like if you just miss there, doesn't matter how good you are, doesn't matter how intelligent you are, if you basically just didn't even allow it to think that way because you said I want answer only from the chunks that I'm sending you, and then you remove
And
the actual answer from those chunks,
and the
worse than
chunks are
hallucination.
wrong.
It's worse than hallucination. So
Yeah,
he's basically saying like, hey, I will never give you a wrong answer, but I'll never give you an answer because you can also say, right, hey, I'm 100% accurate, but I can choose to never give you an answer. That's 100% accuracy,
right.
but that doesn't work. So the RAG is a useful tool. You have to use it very carefully. So I think it depends on underlying retrieval system. So that's why I said neither nor, because I believe that RAG was overhyped and is still overhyped. I think that just think of RAG as one of the step of getting an answer, and it depends on how good that tool is. In certain cases, you can get great outcome, like database, very reliable tool. If I do select something
Right.
star, you know that if it is there, it is get an answer, you pass those things. So I think that
Same thing if you have a knowledge graph and you're able to run a query against that knowledge graph, right? So,
Yeah, so it depends on your tool. So I think that's why the RAG as a system is it depends on how good you have
Yeah,
what.
yeah, and to your point, right? So RAG is an end-to-end pipeline, right? So if early in your pipeline your information extraction is bad, in other words, there's information in the PDF that for some reason you're not able to leverage, right? So it's in a chart or something, but it's actually in the PDF, but your information extraction step is poor, then you're screwed.
That's I think you can still, like figure out how to solve. I think you can get screwed in so many ways. So and the one other problem that you can get completely screwed is
And then to your point, right? So retrieval is obviously key, right?
yeah. So basically triple is the key. Second is how do you even do ranking?
Yeah, 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 yeah.
Like basically, how do you know? Like for example, let's say I want to do RAG because one of the big use of RAG is let's say enterprise search. People talk about that, and I am a big skeptic. And typically, I'm very bullish on AI, but I'm a big skeptic on enterprise search, and I'll tell you why. People somehow confuse that search works on the internet with enterprise search. So the reason why search works on the internet is because you have three key attributes that is true. Number one, internet is collection of URLs or collection of web pages, right? And what these URLs are basically maintained by whoever owns that URL. Like if you have a like instabase.com, it's maintained by us. So we only put the information that we believe is accurate, right? So basically you get a certain degree of correctness because someone is maintaining each of those URLs, and then you have some degree of ranking, right? So basically now you can rank them because I'm going to trust New York Times or MIT.edu more than, let's say, some Reddit post. So
M-
we have the
less, I mean, you have to factor in SEO, yes, but
exactly,
yeah,
yeah. So my point is that so the results that you get is useful.
yeah.
The problem with, let's say, Google Doc, right? Like I have to just search on Google Drive. Let's make this problem very simple. Enterprise search. The reason it's so hard is because which document do you trust? How do you rank? Because people say like if it came from the CEO, that might be more important. I write bunch of my stuff that is completely opposite of what sales teams sell because I might be thinking about future and writing that. It's second, people say the document that is more new is more relevant. That's not true because I might have something that is everybody's enabled our sales comp or whatever, but I'm still thinking about in leadership meeting about what new things should be. So you cannot rank the newer stuff because that might be draft or whatever. So the issue is data quality is an unsolved problem, and therefore controversial opinion two. So I gave the first one about agent is that enterprise search would remain unsolved unless you solve data quality problem. And I have not seen a single solution today that tells you how to solve data quality.
So with that in mind, right? So let's say I use RAG, but in an enterprise application, but only against vetted data sources. Would you say that it would be much more useful at that point?
That is, you made a good point. And basically, yeah. So basically, that is not enterprise search. We call them answer engine, that you have somebody maintaining the quality of that corpus. So for example, we have that and we call this like, this is our basically HR answer engine where our HR team makes sure all the policies are up to date. And so we don't blame if you get wrong answer, like what happened. They are supposed to maintain that. It's basically they are responsible if there's anything wrong. But then
So let me ask you this, Anna. So in that situation where you're super confident this high quality data, how likely it is that if you just use RAG with default dumb settings, that it would produce what you want? You know, RAG out of the box with not much tuning. I'll just chunk whatever the default thing is, embed the way it is, rank and retrieve the way the default settings are. So how much tuning do you still need to do even when you have a gold standard data?
your question is so hard to answer is because depending upon which tool do you use. The different tools have different defaults. Like
Yeah,
some
yeah.
default is better
No,
than
no, but the point is that it might still you know you can't assume that what you're that your rank system will work just because you have gold standard data, right?
Yeah. Because how do they even do chunking? Are they what? How do they find similarity? How do they resolve different entities? So no. So I think that I do believe RAG would be useful, but you have to ensure at the end, look, people have to understand what is RAG. It's generation and retrieval. What is retrieval? Retrieval is finding best match against the query. There are so many different ways of finding best match against query. There is no one technique. Are you doing like the word match, or are you doing basically exact match? Are you doing some fuzzy match? Are you doing some semantic match? Are you using some knowledge graph link? So I think the issue is that you have to understand what does it take to produce best result on your data set. That's the only way you get the best answer. You can't throw in, like for example, you should not be ragging on database. Run SQL query, so much reliable, right? So I think yeah, it's all dependent on the nature of the problem, quality of the data, and the algorithm that allows you to do the retrieval. And these algorithms depend on what is the use case, what the data looks like, and what is the underlying algorithm.
So you talk to a lot of enterprises. So have you guys been brought in and basically fixed some broken RAG application? Like, I don't know. So some companies using RAG for customer support and they're unhappy with the results, and you folks had to come in and clean it up.
So basically, the way we approach our customers is, look, we do one thing and one thing really, really well, and that it will give you the highest accuracy on the planet on this specific types of problems. But in order to do that, we have to understand what the outcome you need. How humans find out that outcome? Like for example, let's say you're doing lending. In order to lending, you get a 400-page long, let's say, packet, which have 60, 80 different types of documents. Each of the documents, you might have different fields. Like if it is a tax statement, then I want 20 fields. If it is, and then once those things come, then I have certain system that says if the name should be taken from the ID documents, not the stuff, then how do you handle those? And so the way we reach out to the customer is like, let's not talk about RAG. Let's not talk about search. Let's not talk about 20 features. Let's talk about when I get an input and a question, how do you get best results today? And we will give you the best results. And we basically have a pretty good understanding of like a lot of those use cases. So yeah, we do go and fix, but we do not go after every RAG problem, because we might not be best fit for every RAG problem. Because as I said, like if it could be some very specific construction ranking or circuit ranking might be very different RAG than, how do you process financial documents? And therefore, we do not claim that we can do RAG on everything. We can do RAG on really two major things: any kind of documents. That's what we are very, very good at. And how do you build the end-to-end workflow? Like even if you can retrieve something, how do you rank them? Are you going to prefer this document answer or that document answer? Then how do you do all the validation? Because it needs to be correct, because something might be wrong. When do you ask for human input? So as of now, we do RAG only on one thing, and that is when you have to make decision where you need very high accuracy. Very high means you want 99.99 times correct out of 100. We will give you the best accuracy on the planet.
Which brings us to another key challenge, which is eval.
Yeah.
So what's your secret sauce then?
Secret sauce. I'll tell you, there's nothing secret. It's pretty simple. How do you do eval with humans? You have checks and balances. So what are the checks and balances? I think people do not realize that humans make today with AI systems. Actually, AI performs at the accuracy level better than humans. Humans make, like if you ask them to, look at 100 things and give you some results, they will get 90% right. They also make 10% error. So how does the world work when humans can make an error? Typically, you have some second human that might check it, or you might have some automated system that validates against certain things to check it. All of those tools are still available. So sometimes people fall into this fallacy that AI needs to be like, out of the box, needs to work like 100%. I'm like, no, you have to design a robust system where even if AI got 95%, you are able to catch exactly that 5%. Because if you have to review everything, then AI is not useful, right? What is the point? So predictability is the key. So the way we do this is, of course, we do our own benchmark on all of the popular problems, and we compare against every AI system and all that. But then we focus a lot more on, and I'll give you, before I complete this sentence, I'll give you one example, which is not very obvious, and people don't pay attention to that. So let's say you go to somebody, and a lot of vendors sell this way, which is I have 90% accuracy for field extracts. So we take a document, you extract 100 fields, we'll get 90% correct. And that seems pretty good. We should pay some millions of dollars to buy that tool. That's what people think. Now let's do simple math. Let's say you're doing tax documents or something, whatever. You extract like, I don't know, 50, 60 data points from 1040 or whatever. So let's say you have 90% accuracy field level. So if you do 0.9 raised to 60 at the document level, you might be getting 2% accuracy at document level. That basically means every document out of 60 fields will have, 2 or 3 wrong. If you don't even know which 2 or 3 are wrong, you have to go and review every single thing. Your value is very, very limited. So 90% accuracy is useless. I think that better system is the one that says, if you process, let's say, 1 million tax documents, 60% of them doesn't require anything. It's 100% perfect. And that's that's 2% to 60%, that's 3,000%, like improvement. And that basically requires a very careful design. And we know how to do this with humans, because humans make error too, right? You have this human, then you have some system that checks this. And I don't know why you cannot do that with AI. So that's why sometimes people say, I see this all the time, which is we can do this with LLM. The value is not in LLM that can give you 90% accuracy. The value is the workflow that guarantees that instead of 2% thing that is end to end, everything perfect, how do you go from 2% to 60%? Right. So, and I think,
But then even when you get to the 60%, how do you know which of the documents are in the 60% as opposed into the 40%?
yeah, no, you need to know that. Otherwise, 60% is not valuable. So yeah, you have to know that. And that's why all the checks and all the, with humans, how do you know which one doesn't require more thing? Because you have those checks, right?
Right.
How do you know that if humans have checked 3 times, I don't need to check again? I mean, so you have a bunch of those systems in place, which you can do as part of those workflows. So, because I think that if you can have one LLM that extracts, what second LLM basically can ask, like, hey, you can ask some adversarial question, like, hey, I think value is this, can you check that? And it'll go and ask. So basically, you can design the whole workflow in a way that guarantees you that you don't need human review, but you have to think this from a system design problem. Like as an agent, how do you design the whole workflow? And then once the workflow comes, how you can run it reliably. That's what I meant, the design time and the runtime separation, which is going to be the key.
And then there's the human who's using it. You need to get them to trust the system, right? So in order for them to trust the system, what are some of the key elements that they need to be able? They need to be able to audit the results, or something, right? So, or they need to have some level of understanding of how the system works, or where it's good at, what it's good at, what it's not good at. So how do you solve the trust problem?
It's a very, very good question. So trust does not come from high accuracy. Okay, a lot of people think this system is 90% accurate versus this 70, so 90% one is better. And that is very counterintuitive. Trust comes from predictability, that I can predict which 70% this is correct, which 30% is not correct. Right? Like, I mean, you trust predictable horse more than unpredictable horse, even if the other horse might be running faster. So predictability is the key. So I think the problem that you have to solve for trust is predictability, that you can predict the behavior of the system in each of the scenario. And that is the reason why I talked about you should not be running agentic in production operational runtime workflow, because you cannot predict which path agent will take. And therefore, agentic should be used only during build time scenario, where you basically do this, but then we'll run this validation when something is failed. So now you know exact path it's going to run in the workflow. And what happens when this path hits? And that's the reason why we can predict human systems, right? When this fails, then they go and say, like, hey, I need this extra. We get annoyed, right? When we go to the airports and other things, which is very predictable path. If you forgot your ID, even a person knows, they will not let you, they cannot use your intelligence. They have to follow exactly the rule. So there is a degree of predictability. Like everybody has to go exactly the same way, put the same thing. You cannot bring liquid in the stuff. So I think the way to sort of solve the trust problem is predictability and making sure the system is predictable.
So we talked about that one of the barriers for enterprises is data and, having that good quality data in order for you to have some reasonable amount of success with AI. So what are some of the other key enterprise barriers that is holding them back from adopting AI or agents or automation in general?
Okay, I'll give you I'll give you this one slightly more controversial than the other two. The biggest
Good.
barrier, yeah, sorry, go ahead. The biggest barrier, I think, is that um, too many people, too many opinions, too much management. So, and everybody wants to talk about things rather than do things. So that's the problem with enterprises. So it becomes very, very hard to get anything done. I don't know how to solve this. But I
So is that Anand, is that because the leaders in these enterprises are not uh, technically savvy enough? I mean, you're one of these unusual CEOs with a PhD in computer science, right? So, but a lot of CEOs are not that aware. They just read whatever's in the Wall Street Journal and then they talk to their team, right?
I don't know. This is very hard. Intelligence is such a hard thing to define. So it's very hard to say smartness or
Or
basic.
just level of knowledge about what's possible, what's not possible, right? So.
So I think, yeah, I basically see the things are changing so rapidly that in order to really you touched upon a good point. So let me expand that, which is in order to really understand new tool, you have to use it, you have to practice it. It's like I think there's a talk by Steve Jobs at MIT long ago where he basically talks about these consulting companies, and they said like they have a really good picture of like bananas and apples and all that, but they've never tasted it. So they come with like, here is banana and here is apple, here is how you should do it, but they don't own the result of their own recommendations. So I think if this the currently the issue is there is so much noise out there, and you get to learn about these systems by actually sort of going in the details of the problem, how it works, how this problem gets solved today. And let me quickly, you can test these things very, very fast.
So basically, understand the workflow you're trying to tackle.
Exactly. And understand like what is the degree of predictability needed? Why do we need this stuff? Like, so basically, rather than like let's apply AI to everything, it's about like,
Well, the buzzword now is we're AI first.
yeah, I mean,
We're an AI first company, right? So,
yeah, I mean, I don't know how to parse that, but basically but I agree in the sense that you have to start with what is the magical outcome, what is the outcome that you're looking for, and then work backward from there, rather than like let's apply AI, because I think that's just really uh, on in like it's not it's hard to really like it's like when you want to do like 20 multiplied by 30, you don't want to use AI. You have calculated that works great, much more reliable and much more predictable. So I think it's very important to know which tool to use.
so I guess we've identified two barriers, right? So one data, the other one seems to be organizational, or and then anything else?
Those are the major ones, but I think but that's always been the case. It's harder, right? Once you get big organization, it becomes hard. You have too many opinions. It becomes very, very hard to change things. But I think AI is still like in general, people at least one thing is common, and is that everybody agrees that it can have a massive impact. So the good thing is everybody's thinking about it. So even though it might take slightly longer, I'm reasonably certain that everyone will use it and everyone will get value from it.
So then if you're in one of these companies, you're starting your AI initiatives, right? So what how do you start, I guess? So I guess one way is let's get our data in order, right? So what else?
No, I think I'll start with what problem we want to solve, what is needed to solve that problem, and let's apply AI. I think
No, no, but then you'd have to rank, right? So we have so many problems. We have to identify which ones uh, are amenable to being solved by AI.
yeah. So let's think about this. So basically, let's say I'm a large organization. I'm talking about what are the things that are most important. So let's say operational productivity or individual productivity, or because these are very different kinds of problems requiring very different kinds of tools. Individual productivity where? Legal, marketing, engineering. If it is engineering, then maybe get cursor and give everybody and figure out how to do things. If it is operational productivity, then figure out how to automate these workflows, understand data. If it is search, giving everybody answer, then figure out data quality and some of those things. So I think that there is just no one, there is no like you start from, because then we will run into um, this massive or same mistake that we made with big data. You might have heard there was a lot of craze about this in 20.
Hey, my Twitter handle is big data.
Oh, super cool.
Yeah, yeah.
So I mean, I think everyone's marketing message was, "What is your big data initiative?" And there were things like data lake and data whatever, and you put all the things in there, and people put all the things in there, and they're like, "What next?"
So I guess the question is, do you just let each business unit run, and then you folks explore, follow what Anant just said, and then you might have success. Team B might have some challenges, and then you talk to among yourselves, find best practices. And because there's also the danger of everyone doing their own thing, and then suddenly you have 500 different frameworks.
That's a very good point, which
Yeah,
is, but that you talked about how rather than what.
yeah,
So now the what can be decided at the very, very top of these are this organization's five biggest things
yeah.
that we should look at solving. And those could be developer productivity. So I'm not saying that everybody should come with their own idea and you have 5,000 tools and you should do nothing. But I think that the right way for enterprises to think about is what are the core areas where AI can produce massive outcomes. And some are very clear. One is, let's say, developer productivity. Second is operational productivity. How do I do the operational workflows? That's where we fit in. Third one, where I'm skeptic, enterprise search. How we get everybody that they can find information because they spend a lot of those for. Fourth one is very, very specific to the department, like legal. We get so many contracts or we are in so many different lawsuits and we don't want to pay lawyers so much money, so maybe save like from 20 million to 5 million because it can help. Or trade. So basically you can, so at every organization level, the right way to think about this is here are the 5 or 6 massive problems that we deal with, which must start with the problem rather than data, because that problem is going to define what you need and how to solve it.
So in closing, so you're at the front lines of enterprise adoption of these tools, right? So, and obviously, you may not be building your own foundation models from scratch, and so you're just like the rest of us. You're eagerly anticipating releases, evaluating, figuring out uh, how to use what model in what scenario. So, if you were talking to the foundation model builders on a regular basis, what kinds of things would you like them to work on or improve or add to the capability of these models that will benefit what you're doing for enterprises?
Just one, predictability. So I think that is basically, because if you can ask the same question to 3 times, the model might give you 3 different answers. So predictability is going to be the number one. Second is some degree of explanation or auditability of how it came to that answer. Currently, there is no way to know that. You might have log probability of tokens, but token one followed by token two with this probability followed by token three. So that doesn't give you much.
Yeah, so some of them are starting to pump out like the reasoning steps and tokens they're using for as their reasoning, right? So but then you still have to uh,
Yeah. And you see those tools that do that very successful. Like the reason why Cursor is successful is that it tells you like, oh, but Cursor's reasoning is not really like what I'm thinking. Cursor stuff is, okay, here is how I'm going to approach this problem. I'm going to go and grep these files. Once I find the relevant file, then go do the analysis on that, and that gives you confidence. So I think being able to explain like how they think about this so that you can know like what it did, what data sources considered, what it missed. Um, so those are the two major ones. I think most of the model companies nowadays are.
let me add one more, which is I want the smaller I want you guys to prioritize the smaller models in the following sense. I want the smaller model, the gap between the smaller models and the bigger models to be less, and so that I can run these models cheaper and on smaller devices and so on and so forth, right? So
Yeah, those are useful, but I
because
think maybe my point is like those are you overcomable. Like if I know like hey, I can make an API call, and generally as long as you give high
well, but that's my point, right? So I don't wanna code. I want to be able to code on my laptop and not connected to some supercomputer in the cloud, burning through tokens, right? So I at some point I want some reasonable way to do things even when I'm offline, right? So
yeah, I agree. And on phone and bunch of privacy and those are the things. It's just that for us, I think the predictability is my number one priority.
yeah,
How do
yeah.
we give every customer an outcome that they predict? I care about predictability more than accuracy. You can be 80% accurate but unpredictable. That's not good. 70% predictable, like when you're accurate, when you're not accurate, is much more valuable.
I are you seeing any progress in that dimension? I,
There are basically things around the models that are being done to give the predictability. So basically, with the tool use and one model
yeah,
thinks it's a
yep.
dangerous step. So I think that there is system design that's happening around the models. It's hard, right, to do at the model level because that still remains a black box. You have,
That's a black box.
yeah.
Yeah, yeah. And with that, thank you, Anant.
Thank you so much.